You're listening to the Talking Air Filtration podcast, where you get to know the people that make air filtration possible and help us all breathe easier. Because clean air matters.
We'll get insights from air filtration professionals and learn how they became successful in their careers. Along the way, we will discuss best practices, guidelines, trends, and challenges in air filtration in a variety of applications. We hope HVAC, air filtration, and indoor air quality pros, including business development, engineering, building owners, and facilities management, will enjoy the insights our guests will bring to this podcast.
I would like to bring to the stage right now an amazing friend. He let me be in his band in high school. First time I ever toured internationally. He was actually the choreographer for NSYNC, and I learned a lot from him. He's an amazing singer, all the way from Kentucky. Bobby Singer! Woo!
Thank you. I don't know how to follow up this guy. We're going to have to bring a lot of energy on this panel, obviously. Again, I'm Bobby Singer with Blue Heaven Technologies. Thanks to Steve again for all your work. When we first talked about putting a panel together for filtration testing, 3 names popped into my head. And we're all fortunate enough that I was able to land all 3. So with the rock star, it's going to continue the whole rock star thing because our 3 panelists are absolutely rock stars. So what we're going to do, we got 3 presentations, probably around 10 minutes each. We're going to let them all do those presentations and then have a question and answer afterwards. So the slides may call for questions at the end, but we're going to wait until they're all 3 finished and then just open it up for discussion. Our first speaker, you might know the name, Bob Burkhead. Bob founded Blue Heaven Technologies in 2004. I'm really glad you did. He's now semi-retired, but still consults with Blue Heaven on a regular basis. He has over 45 years experience in filter development, production, and testing. Bob has served on countless committees within ASHRAE and ISO. He's a past recipient of the NAFA Lifetime Achievement Award. And even in his retirement, he still is on his quest for indoor air quality. His quest continues to this day. So, Bob Burkhead.
Howdy. How are y'all? I tell you, it's going to be hard to follow up this guy that just talked. But one thing I did notice when I introduced myself to this little program you had was all the neat young people that are in here. Look around. There's not that much gray hair anymore in here. And that's a good thing. I'm just glad to see it. Thank you all. Certainly the 5 that I talked to. And I did talk to one old fart. It was Jeff Holt. But other than that, we're here to talk about history and future of filter testing. And it's just exciting stuff. We'll keep going. This is a drawing out of the ASHRAE 52.1 document from 1992, I think is the last version of it, yeah. So it was used in the National Bureau of Standards testing back pre-World War II. They were already preparing for nuclear war. And they had no way of measuring things, particularly in the air. And this was going to be the way they did it. It got developed into an AFI Air Filter Institute standard that was used, and then later ASHRAE Standard 52 in various formats from 1968, ASHRAE 5268, and that predates me even. The newest one was 76, and that even predated me a little bit too. This is the schematic from the 52.1 document. It shows the test standard, shows the duct, and you can see the 2 little dust feeders in there. So you might ask, what the hell did it do? I mean, it's a dust spot sampler. What's that do? You sampled a target, pulled air through it, stained it, then what? You shined a light through it, and you measured the opacity. We have a few opacity meters still at Blue Heaven. Yes, that's the way filters were tested. It sounds like smoke and mirrors because it actually is smoke and mirrors. But it was the way you evaluate a product, and it was the way. Old heads like us, you say ASHRAE 52 or ASHRAE 45%, ASHRAE 95%. This is what they meant. an ASHRAE dust spot measurement. So that's just a little snip of history about the ASHRAE protocol. If you want to know more, there's a really nice article that got published in the ASHRAE Journal in 2020, written by some colleagues of mine, Brian Craftifer, Marilyn Lispan, and Barney Burrows. If you know Barney, you know there's this flourishing style, and it's a neat read. If you're really interested in understanding the history of it, that'll bring you up to speed. Go find it and read it. Okay. I want to complain about one little thing going on right now. Even historically and in the future, I'm afraid it's going to continue to happen. It's misuse of the term HEPA. I think all of you see the misuse of the term HEPA all the time. And that's what this was about. It's a pet peeve of mine, and I'd like to just preach about it for a moment. If you get an opportunity to stop the craziness that HEPA applications talk about, please do it. It doesn't mean anything other than it's a specific removal efficiency on particle sizes in a very specific way. Does that mean a device is a HEPA device? No. It just means the filter could have been and could have performed that way. Don't misuse HEPA. I mean, it's not even particulate that they're talking about here. It's something other than particulate. So I'll try to be quicker than I've been going. What's next? We need to talk about the future too. And this is what I call pedestrian of importance, that normal things are going on that you need to be aware of if you're not already aware of them. Domestically, you know this. ASHRAE publishes a lot of test protocols. They love their acronyms. The MOT means method of test. You know one very well, ASHRAE 52.2, ASHRAE 145, the gas phase version of it. ASHRAE 185 is being worked on now. Kathleen will talk about that. And all the IAQ standards internal to ASHRAE, those are published too, and more are coming. There's a new one called 241 that Kathleen will talk about in depth in just a second. But globally, there's also a lot of work going on, and I've been involved with that quite a bit. Don has been involved much more than I have, and he'll talk more about that in just a second. I want you to see the impact of what goes on here. There are 27 published standards in ISO TC 142, 27 of them. A lot of work, a lot of compromise, a lot of give and take. There are 20 more being worked on. This is straight from their website. So there are new ones coming all the time. If you know how ISO works, it's each country gets one vote. So there are 22 what they call P members, voting countries involved with this. So it's a global effort for sure. And there are 20 other countries observing what goes on there. Now that might bore you to tears, but it's the global approach to testing filters. And I want you to look at this list of a dozen or more working groups where lots of work is going on. Don is going to speak a little later. He is the convener, Working Group 3, the father of ISO 16890, which you will talk about, I believe, in depth. Globally, that's the thing. ASHRAE 52.2 is nice. We're in the US, so we use it a lot. But if we're going to think globally, we have to think outside that box. And that's the message I want to get across to you. We live on a globe. We should act like it. And I realize how naive that might sound to a lot of you, but we have to start trying, or continue to try. It's my message about all this. Last thing here, I want to just close. We have a home in Vero Beach, Florida, which is right down the street from Port St. Lucie. We're one of the biggest nuclear power plants in Florida. It's right on the coast. Right next to the nuclear power plant is this beach on the ocean. It's called Blind Creek. And I want to point out a few things. If you'll notice, it says no alcohol. Okay, maybe we can live without alcohol at the beach, but that's kind of redundant. It also says no dogs, and that's just sacrilege. You should be able to have your dog with you if you want to. But if you'll notice, it has one other little thing going on here. Clothes are optional at this beach. So in my investigative sense, I made sure that I checked this all out. And believe me, there are things you can't unsee, and you don't want to run that effort. But what I did learn is if you can't have a beer at night with your dog, you might as well take your clothes off. I'm done.
Are your air filtration personnel NAFA certified? Ask if they belong to NAFA and have their certified air filter specialist or NAFA certified technician designations. The CAFS and NCT designations are earned after rigorous exams and demonstrate that the air filtration professional has a high degree of knowledge and professionalism. To learn more about NAFA certifications, visit nafahq.org.
Bob. Kathleen Owen is up next. Kathleen is the owner-operator of Owen Air Filtration Consulting. She is an expert in air filter and air cleaner efficiency and testing. She is a current member of ASHRAE 241. She chairs ASHRAE Standard 185.5 and is past chair of both ASHRAE 52.2 and ASHRAE 145. Kathleen has completed 3 ASHRAE research projects on various aspects of air cleaner testing and use. She also holds the prestigious honor of being named an ASHRAE Fellow.
I'm basically here to give you a short talk on the 185.5 P. P is because it's proposed. I'm going to start, but I want to preface it by saying one of the reasons for talking about this is that we have ASHRAE 241, which is a new standard for getting buildings prepared for pandemics and how to operate in pandemics. And one of the pieces of it, there's a number of different sections, but one of the pieces of it, and the part that I'm involved with, is how do you use air cleaners to help provide clean or cleaned air so that you don't have to just use outdoor air to provide your pathogen-free air. So that's kind of the background for why some of this material that I have in my talk is more important, because we have a lot of ways to determine how well your MERV filter or your HEPA filter works. There are a lot of devices out there that we don't have. So, and of course, I can't actually read the screen because apparently I need new glasses, so I will do my best. Everybody here probably knows that there's filters. If you don't, you're in the wrong room. But there's also electrostatic precipitators. Another type of device that doesn't actually remove things from the air, but can kill them or inactivate them. UV, ultraviolet light, and UV PCO are often used for just making the room not contagious. It doesn't make your PM levels change. But there's also a lot of air cleaners out there that I call reactive air cleaners. We have several different terms going on. It's in such a state of change within ASHRAE and the world that we're calling them all sorts of different things. But basically, talking about air cleaners that are put into a space and they put something into the room to cause reactions to make things go away. There's not a lot of ways to test whether that works, because you can put it in an AHAM chamber and get a CADR. But most of the devices, or a lot of them, are put into ductwork, so you can't do a chamber test. So that's why we've moved on to having to fill this void. And as I don't like to talk about my slides in order, because there are in-room units and there's duct mounted, and some of them work in different places than you might imagine. So one of the important issues that we have is which tests do we have and where do filters work. So obviously, everybody here knows you can put a filter in an in-room device or you can put a filter in the duct. They both work. There's tests available for figuring out how those work, with the caveat that the in-room test is supposedly only used for residential filters. But if you see a CADR or a CATER, that's from an AHAM test. There's then with UV, or things that are intended to kill pathogens, inactivate pathogens in the air. There's a UV test out there for single pass. There's in 52.2, we have an optional appendix for doing it for any other type of device. So it's covered if you put it in the duct, and it works right there at the device. Then we move on to other types of air cleaners, the reactive air cleaners, especially types that say that you put them in the duct or you put them in the room, but they have to work in the space. They don't work in the device. So because we need to have information on it, there's a lot of these devices being sold. And people, on the two sides of it. One, we need to know if they work, and one, we need to know what they're also doing. So we started a test method, ASHRAE 185.5P, and this is what happens when you get a committee together. You get a really, really long title because you included just about everything, but it tells you we're a test method for HVAC and duct-mounted devices as long as you need the airflow through a side duct. And people ask me, what kind of in-room device needs a side duct? I don't know, but there are people in the group that said that they do, so we included them. But it does mean that you could use this test for an in-room device as well as a duct-mounted. The main purpose in terms of most people's minds is that we're looking at pathogen inactivation. So inactivation or removal, because if you do a microbe test and they manage to grow on a plate, you could either have removed it or you could have killed it. But the test also is going to have a particle section. So the people who are true filter people, just straight filtration, we do have a portion of this test that is going to address just particles, but particles for an in-room or a side duct-mounted or duct-mounted device that works in the room. So I'm trying to get some of the particle people to come and join me at 185.5 because I only have 2, I think, right now. So this is, you can read this online, but basically our scope covers exactly what I've just been talking about, but I put it up there anyway. What will be included? We are still writing. We've only been a committee for about 7 months, and contrary to 241 coming out and getting done in 4 months, it normally takes a few years. I'm hoping to get done in a year. But we have to decide what are going to be our requirements for the chamber size. Like an AHEM test is a 1,000 cubic foot chamber. Well, that's not big enough if you want to put a 2,000 CFM side duct on it. So do we need to say 4,000 cubic foot chamber? Those are questions that we're asking. I think we're going to end up with a range, but I have a group working on it. We have to decide what we're going to allow in terms of duct airflow or what we're going to require. How are we going to generate either the bioaerosol or the particles? How are we going to say that we can measure them? What types of things like temperature and humidity? I mean, all those things you have to have in a test standard. Everyone knows that stuff. The biggest fight we're having right now is what kind of output do we want? And I'm assuming that we're going to end up with something along the line of a CATR. In 241, that's the new pandemic standard, it's called the VECA, so it's the equivalent clean air amount, but it's basically the same thing, but it's something that if you put that device in the same conditions, you can add it to other air cleaning that you're doing in your space and come up with how much total air cleaning you're doing or how much total cleaned air you've got. And what I want you to remember is we have devices out there that don't have tests. We have standards like 241, and for that matter, the IQ procedure in 62, I think it's 1, that need the information for especially reactive type air cleaners, but devices that work in the room. We are working on getting those tests. There's several other test methods, as Bob was talking about. ISO is working on quite a few of them. The ASHRAE, as far as I know, is the only group that's working on the ones with the side duct, so for duct mounted, but chamber efficacy measurements. We also have a gas phase group as 145.4. We're still being written. If anybody wants to come help do the writing, great. If somebody wants to come and tell us we're doing the wrong thing, be nice about it, but I would love to have more input because, as I said, we're missing particle people. We have a lot of bio people. We've got a good group. They're new to ASHRAE mostly, and it's been fun working with them, but I could use some tried and true people. Anyway, that's next person. Thank you.
Thank you, Kathleen. Next up is Don Thornburg. Don is a graduate of NC State University. He's been involved in HVAC and air filtration for over 40 years. He is currently the Filtration Research Manager for Camfil USA. He is past chair of ASHRAE 52.2 and convener of ISO TC 142 Working Group 3. He published the ISO 29462 in situ test standard, the ISO 15970 loading dust standard, and also his topic for today, the ISO 16890 standard. Don Thornburg.
Well, thank you very much. Really appreciate it. I'm trying to figure out the best way to do this because I cannot read that. We figured out something, or I guess it was last night, that all 3 of us are past chairs of 52.2. We didn't really realize that. Yeah, Bobby's next. So, anyway, let's talk about 16890. I'm sure most of you have heard of 16890.
It is, as Bob described, it is basically the global filtration standard. But a little bit of history. The document was actually started in 2010. We didn't have a number at that point. We just knew we were going to be developing a new filtration standard, a laboratory filtration standard. And what I did is I told the working group, I said, look, I want you to go and take 6 months. And in that 6 months, I want you to come back with proposals on what we're going to do and how we're going to do this. What I don't want, these are the only two rules. I don't want 52.3. I don't want EN 779B. Forget what we have done. Let's look at what does the industry need? What can we do to change the industry, to help the industry? That's what our marching orders were. We met at, like I said, in 2010 at ASHRAE in Orlando, and we set up to start the work on 16890. And we had 3 goals in mind. Those goals were, one, to develop a rating value, or rating system that had value. Got to understand where we were at this point. We're talking 2010. 52.2 had been out for 10 years at that point. Very few people actually knew what MERV was. They were still speaking 52.1, 85%, 95%, or 90-95, 80-85, 60-65, yada, yada, yada. What had been around since 1968. That's what they were still speaking 10 years into 52.2. So it took a while for that to catch on. And one of the reasons it took a while is because how do you explain MERV? There's no real easy way to do it. Well, a couple of the people who made good proposals on doing this, and that's what we have done for 16890, and I'll get to the details in a minute. But that was goal 1. Goal 2 was fix the issues with 52.2 and EN 779. And for those of you who don't, EN 779 was the European version of 52.2. It was the European filter test standard. So there are a number of issues with those 2 documents, and so we set about to fix those in our process. And the third thing was speed up the test. If you look at 52.2, and I'll speak mostly about that one since that's where we're all from, so to speak. 52.2 has a number of parts that make it a very long test to run. And so we want to see if we can fix that. So we set off in 2011. The project was officially started, published the documents in 2016. Now, 5 years sounds like a long time. 5 years to develop a standard is actually lightning fast. Bob was talking about 52.1, the last revision, not blank page, start over with a new standard, but the last revision of 52.1 started in 1976. It ended in 1992. It was 16 years to modify a standard. 52.2, if you look at it from when the committee was reassessed or rebuilt, because what happened was the committee was formed, then they went to research, they disbanded the committee, and then the research was finished, and then they started over with a new committee. If you go from the start over date to the end date, 52.2 was written in 7 years. And that was the record at ASHRAE for the fastest standard had ever been written. And that was Barney Burroughs who did that. He was, I credit Barney, he was my mentor in starting this. So I'm not sure if that's a good thing or a bad right now. He got me involved. But yeah, that's what it is. But this is one of the things, the ISO procedures and the way they go about it, 5 years is about as long. You can actually go 6. That's as long as you can go with an ISO standard. So if you go past that, they disband your committee and start over. You have to get the work done. And so that's a nice feature within ISO. So the issues that we have with the existing standards, first one was EN 779, the European one. The biggest problem we had with that, or one of the biggest problems we had with it, was they did not do a really good job defining the test rig and defining how you qualify that test rig and what kind of testing what validation do you do on that test rig. What they had in EN 779 was loose is the best word I can use. It's one of the reasons that every round robin they've ever run in Europe on EN 779 has been a, try to clean this up, a disaster. Because if your ducts are built differently, if your sensors are in the different places, all of those things, it matters, and it will change your results. And that's the reason that 52.2 was very well defined and this one wasn't. But that was the first problem. The second one was DEHS aerosol. DEHS is an oil aerosol. It's a liquid aerosol. It is a very, very good aerosol for measuring below 1 micron. Once you get above 1 micron, it's hard to get big oil droplets out. It just doesn't work. So DEHS works really well below 1 or below 1 micron, but it's not very good above. And because of that, with using, that's what EN 779, you could really only get an efficiency value up to maybe 1, maybe 2 microns, and that's it. You certainly couldn't go to 10 like is required for 52.2. Third item that we saw as an issue was the discharging step. What they allowed you to do was take a piece of media, not out of the filter, but supposedly the same media that was used in the filter, dip it in IPA, and then retest it. I won't even go into the number of problems in that method, but there's a lot of them. So then, stepping over to 52.2, another aerosol issue, although not quite the aerosol. It's not the problem of the aerosol. Potassium chloride, that's the aerosol for 52.2. It is a solid aerosol, a solid particle aerosol, not a liquid. KCl, because it is a solid particle, when you generate that aerosol, what's going to happen is you're going to induce a charge onto it. And so the standard allows for you to neutralize that charge, which is what you need to do. There's a couple of different ways of doing it. The way Kathleen reminded me a few minutes ago that the way it was done in the research work that developed 52, it was done with a radioactive source. Best way to do it. It works very well. Nobody uses radioactive sources anymore. Think about the word radioactive and how much bureaucracy do you now have to go through to have a radioactive source that you didn't have to have 30 years ago when this was all being written. Times have changed. So most labs use ionization to do it, to try to get a zero charge. You can get your system set up, you can get it working, it's dead zero, everything is great. You run the background counts, you go to run the efficiency count, and you're no longer zero. It changes that fast. And so it becomes very difficult to actually decharge or get a neutral charge in the aerosol. So that is a major problem that we have. And the result of that is every size channel from 0.3 to 1 micron, with the KCl like that, you're going to get a higher efficiency than what you will just simply based upon the charge. And we're not talking about 15, 20 points. We're talking about 1 to 5, but it is a consistent 1 to 5. So somewhere in there, and it is, it's measurable and it's definitely there. So that is a problem in that 52.2 E1, if every value that's run on pretty much anybody's duct is an overstatement of actually what the performance should be. And last but not least, and probably the most favorite subject, the conditioning/discharging. Appendix J. I'm rather familiar with that. I was chair when Appendix J was put into 52.2. Appendix J was exactly what I think both Bob and Kathleen mentioned earlier, and that is what happens when you write a standard. It is nothing more than a compromise. That's what it is. You can't go in there and it all be your way or all be somebody else's way. You've got to work out a compromise. And if you're not willing to do that, quite frankly, I don't want you on my committees. I want people who are willing to compromise. I can work with anybody, but if you're just going to sit there and say no to everything, you're not helping. you're making it difficult. And that's one of the problems we have, especially right now, is there just seems to be a lack of compromise on the way things are done right now. And I'm not just talking about filtration. Think about what's going on in the world. So how did we do this? Well, we looked at goal one. We had 2 of the 35 responses I got from the working group. 2 different people from 2 different countries on 2 different continents came up with very similar, not exactly the same, but very similar proposals. And their proposal was, let's see if we can relate the efficiency values that we're measuring to PM, particle matter. That's what we had a long discussion about this, and we came out of that Orlando meeting with a decision. That's what we're going to do, and so that's where we took off with. So with 16890, instead of a MERV value, what you have is what are called EPM, and that's efficiency PM values, and you have it in 3. Well, technically, I guess there's 4 different categories. I'm only showing 3 here, but there's EPM 1. EPM 1 is comparable to ASHRAE 52.2 E1. It is basically the result from 0.3 to 1 micron. Okay? EPM 2.5 is not E2 in 52.2. This is where it starts to differ. It is the combination of what would be the E1 value and the E2 value, because PM goes from everything below the value. So PM 2.5 would be, well, in this case, it's called PM 2.5, but technically the way the channel boundaries are in the particle counters, it's actually 0.3 to 3 microns. So that's what it is made of. EPM 10 is not just E3, it's E1, E2, and E3. So you take the entire data set, and went into calculating the EPM 10 values. Okay? So what that will, if you think about that, E1, that filtration values below 1 micron are now a part of E1 or PM1, PM 2.5, and PM 10. So it's very, very important that the filter actually works. That is a big part of how this works. For goal 2, fixing EN 779 and ASHRAE 52.2, we put the stringent qualifications and the rig qualifications from 52.2, we literally picked it up and dropped it into 16890. And then had to reword it into ISO formatting and all of that. And we did update a few things. But that's basically what we did. Because 52.2 was very well written. It does a good job on the qualifications. So that's what we have in 16890. As for the aerosols, easy way to solve it. We use 2 aerosols with 16890. We don't test with just DEHS or just KCl. We test with both. Not at the same time, but we test with both. So what you end up doing is you end up running 2 efficiency tests. You run one with DEHS and you run one with KCl. And that's what you do. So you'll end up with both. The KCl, you'll use that data from 1 micron and above. You'll use the DEHS data from 1 micron and below. And that eliminates both of those problems that we had with, in 52 and the problem in EN 779. Discharging. Discharging is required in 16890. We absolutely do discharge the filter. Yes, we know that. No, we do not rate the filter on the discharged value. We do not do that. We take the discharge value, the clean value, average the 2 together, and that's where the rating comes from. Now, I'll be the first to say, I don't like that. I don't like averaging 2 values to get a rated value. That is not the way I like to do things. Remember that word compromise. That's where this came from. When your choice is doing an IPA vapor test that takes very little time, does not tie up with your rig. You're not tying up a $200,000 piece of equipment. You're tying up a $5,000 piece of equipment that has a very small footprint. When you're looking at that and you're looking at the time involved and the money and the cost to run Appendix J versus this, it's a compromise. And that's what we chose to do. The value you get out of that, the average value between the clean and the discharged lines up really freaking close on almost every filter we've tested with Appendix J. Appendix J is challenging the filter with a very, very large amount of ultrafine particles, less than 0.1. Millions of them, trillions of them. That's what you're doing, because that's exactly what that filter sees in real life. That's what's in the aerosol that we breathe. It's the vast majority of it. We can't see it, we can't feel it, we can't touch it. We can't even measure it without a $100,000 piece of equipment. It's very, very small stuff. And that's what Appendix J uses. That gives us it's very, very close to what we find in real life. Now, real life, what does that mean? Depends on where you're at. It changes. This is a method of test. So our point here is what we need to do is whatever we do to one filter, we need to do to all of them. And so that's what the discharging was all about. So point is we don't use the discharge value, but we do discharge and we use the average. Then the goal three was speed up the test. Well, we found a really good way of doing that. We made dust loading an option. We don't dust load the filters. The reason for that is quite simple. Dust loading in a 52.2 test is probably the single most expensive part of that test. It is a heck of a lot more expensive to run the dust loading than it is to measure the efficiency or even do if you're doing the discharge. Well, we'll get to that in a minute. But it is much better if you do not have to do that, especially when the value of the data coming off of that is sketchy at best. I mean, I give talks to people all the time, and I say, okay, here's how many of you have ASHRAE dust coming through your system, coming through an air handler? And anybody? Have you ever seen that? Because my sales guys would love to know about that, because you're changing filters every 4 hours. I mean, that's what dust loading is. You are loading a filter with a huge amount of aerosol or dust that it doesn't see in real life. The final filter especially won't see that. Pleats might, but they don't. A final filter that has a pleat in front of it or has a second or a pre-filter in front of it, they're not going to see any of that. They're not going to see 8, 10, 20 micron particles, which is what ASHRAE dust is. So there's very little bang for the buck, if you will, on that process. We realized that. That's what we changed in 16890. Any of you who were at 52.2 in June, you've probably heard me. I made a proposal that we do exactly that with 52.2. We dropped the dust holding capacity test. It would save us a lot of time, a lot of money, and it would be a nice compromise. The unofficial goal, this came about afterwards and really came apparent that this actually did what we wanted it to do. We had talked about it, but it really wasn't one that we wrote down and said we were going to do. I did a talk probably it's about 5 years ago now, INDA. And there were two guys in front of me who spoke. Both of them were media manufacturers in Europe. And both of them, their talk was about one thing: the changes they were making because of 16890. Media that they would make that they knew would start off as a MERV 15 and drop to a MERV 11, MERV 10, somewhere in that range. As soon as you started running air through it, they're changing that media. They're improving that media so that, okay, yes, it drops, but it drops to a 13, not a 10 or 11. That's an improvement. That is a strong improvement to our industry. That's what we need. I don't have a problem with charge media. I have a problem with the way it's marketed. If you're going to sell somebody a MERV 15 filter, it should be a MERV 15 filter day one to day last. That's the problem. And that's what we need. 241 shot they put a shot right across 52-2's bow. And for those of you who are really young and don't know what that means, that's the US Navy's version of a warning shot. That you better not do what you're doing because the next one's going to come right through your chip. So that's what they're doing. 241 gave 52-2 a year to get it fixed. Right now, 241 was just published. It says you can use MERV values. As of January 1, 2025, MERV A, they're going to make the decision for us. So 52 needs to get off there and do something. We either have to, adopt Appendix J, or we got to do something. We could adopt ISO. I don't care. We could adopt the procedure out of ISO. I don't care. We have to do something. And that's the problem we have right there. And that's it. Thank you.
Thank you, Don. Do we have time for a few questions? I'm going to guess there's more than one question, but if anybody has a question, we'd be happy to hear it. The question was, if you don't perform dust loading, how do you determine the life of the filter?
Yeah, I left one little part out. The only time you have to do dust loading is when you're dealing with an arrestance product, an arrestance filter. So that's MERV 4, 5, 6 along in there, the really low end stuff, or the arrestance side. That's where you have to do it. Now, let me ask you this. If you have a filter that has 100 grams ASHRAE dust loading and an identical looking filter that has 300 grams of loading, which one's going to last longer in the field, in a unit? Depends. I could show you data, and I made this comment at a place one time, and there's a very, very, very really good friend of mine. He was actually Bob's mentor. Is a gentleman named Chuck Rose. Worked for AAF for 40 years. I love Chuck to death. I made that comment in a 52-2 meeting, and Chuck looked at me and he goes, "And I've got the same data."
Yes.
ASHRAE dust loading does not mean the filter will last longer. It means it will last longer in that test. You are not loading the filter in real life with ASHRAE dust. I mean, like I said, show me an air handler that does that. That means you're changing the filters out every 3 to 4 hours because you're going to hit 1.5 inches in 3 hours or 4 hours.
May I respond? Can you hear me? Dirk, you're right. You can't measure life unless you go measure it, actually. So this doesn't mean taking it out doesn't mean you can't do it. It just means you don't want to do it in this method and complicate the other issues that you're running because they're important too. Doesn't mean you can't go do a dust holding test if you want to, and that's what will happen. The whole industry seeks some definition, some prediction of life. So you got to do it, but it's not internal. Wouldn't be required to be internal to the test method. The change got accepted.
Yeah, the proposal at 52.2 is it's optional. It's not to take it out completely. It's make it optional.
One other way we've discussed at 52.2 of doing it is instead of doing 4 dust loads to get to that final dust holding capacity, to do 1. And then people could still get the number, but you would save all of that dust loading, all of that cleaning up the rig, all of those efficiency tests in the middle, and you'd still get essentially the same number. So in other words, there's questions about whether that data is useful, but if it is, if you made it optional and you just did 1 dust loading, it would save money. And one thing at 52.2 that we talked about is if we put Appendix J in, it costs more to run than the 30-gram dust load step. But if we took off the other cost, we could even some of that out. So that's one of the pushes or one of the reasons I support what Don suggested. Yeah. But yeah, you could get that number. But the other thing is a lot of filters are pre-filtered, especially the ones that have a lot more media, the MER 15s with the V-cell mini pleats and stuff. They're not seeing the big stuff that's going to give them any useless. And a lot of people change them out on schedule, 1 year, 2 years. Yeah.
I'm curious about something. Y'all sell filters. How often have you been asked for 16890 data? Anybody in the room?
Ooh, we got to work on that.
I know of at least one we've talked about, but it's just not there yet. And it's a much broader issue in my mind. I'm sincere when I tell you we need to act and perform our jobs as if we lived on a globe. And I know how silly that sounds. I mean, we can't even agree on what a good president might be. But the point is, if we don't do this, if we don't have a common ground to judge everything on, mistakes will get made. And it's mistakes that can be life-threatening. So we need to do this. Now, it's not going to be perfect. 16890 has its own warts. I mean, there are 49 rankings instead of 16. MERV 1 through 16, that's nice. Now you got 49 to deal with. So, there are going to be issues with it, but we're going to learn. And we need to learn about this global application of something because it's the smart way, the efficient way to judge things.
Thank you all.
We're not here all day?
Thanks for listening to the Talking Air Filtration Podcast, a production of the National Air Filtration Association. Clean air matters.